Oh, hello. What's happening? We're back yet again. What is this, like 8 days? I mean, no weekends, but 8 days? Not bad, if I do say so myself. All right, I think we're all set. Recording, yes. Microphone, check. Chat window up. Si, senor. I think we're good. I think we got this all set. Oh, we're getting good at this. Today's been a hilarious day. I don't know how everyone else is doing, but I stepped in some Twitter some Twitter garbage today, and that's been fun. Always good. Booty Dab, what's up, Nil? How you doing, man? We're still working on some algorithms. We're gonna start in just a few minutes. Just, you know, gotta get locked in. How's your day been, man? Hopefully. What's up, Jessica? How we doing? Yo, yo, Gateway Productions. Oh, man. We're just chilling for a little bit. It's all right. Yeah, you doing anything interesting? Dude, having a streaming schedule has actually been so good for my, like, ridiculous inability to do things with ADHD some days. Because it's like, I'm like, I want to do streaming so bad that I have to get everything done in a compressed time period. So it's just like, I'm going to get it all done because then I don't have to do it later at night. And it works. It's actually working quite well. All right, here. Let's see what the old Gemini does. I want to add something else to this. Okay. So create a stream starting soon banner image. This started as a joke originally that this message was just my stream starting soon banner. But then I like to see what Gemini can come up with. The streamer name is Thoughtless Labs. And he streams coding and yapping. Let's see what it comes up with. I like to see what it does. Dude, being on the internet is so wild. It just is hilarious. People lose their minds. Well, Gemini, you did it exactly what I said, which I guess is good. Gemini loves that streaming light. I love it. I love it. I love it. I love it. Okay. So I'm going to kind of just jump right in pretty quickly here. I just want to check a few things. Make sure that I got these things done. That's sent. Being on the internet is actually wild. Yeah, dude, it's nuts. People just lose their minds over things. It's kind of amazing. Like, I don't even really know what to do with that, with the information that I find on the internet half the time. Because people are wild. All right. I love this song. It's funny, my son hates this song. Like, absolute plugs his ears in anger when I play this song. But I don't know why. I love it. It just gets me going. And I'm not even like a huge Skrillex type guy, but this song just slaps, baby. Okay. Yesterday, we were working on technology is great. People just go crazy not knowing how and why. Yeah, it's true. Technology is amazing. Like, it's so cool what you can do. It really is. And, like, that is, I know, the least exciting sentence in the world. Like, the most obvious thing, that technology is cool. But it is wild, the things that come out of people's mouths. I mean, don't get me wrong. I like to say a lot of ridiculous stuff, but sometimes I get surprised. about what comes up. People get mad. You know what? I will say this. I was definitely a lot more angry on Twitter in like my mid 30s. You know, I was starting to have kids. I was tired. Everything. It was the start of everything feeling like it was going to poop. And I would just get so mad at so much stuff that was happening on the internet. And then I got a little bit older, started getting a little more sleep, and it was just like, oh, good to go now. Day so far is good, Nil. It's solid, man. I've just been a busy day at work. Got a couple big projects done though, so that always feels nice. I have one more that I really need to finish, but I was like, you know what? I'll stream and then I can just do it this evening. I need to be done it for tomorrow, so why not? For me, I still can't get through the reality of picture, let alone videos and live stream. Capturing live moments in real time is just mind-blowing. It's true. And especially like how good it is. Like the quality is insane. I was talking a little bit about this yesterday. Just like it's incomprehensible how fast computers actually are. Like, whenever I'm trying to code something, I'll like try and think through it in steps. And sometimes I'll be like, oh, that seems like it's going to take forever. And then it's like, no, it's a computer. This will take no time at all. Like, it's amazing how fast they can do things. And they just keep getting faster. Oh, so yeah, I was just going to say, yesterday, Merge Sort destroyed me. I don't know what happened, but I just could not figure it out 126 years ago. It was just Merge Sort. It destroyed me. It sorted you? It did. It sorted me. I had to revert. I had to go and use Boots to help me out. And which was fine. That's why Boots exists in boot.dev, is to help you. But I was saying yesterday, like, it feels like using a Game Genie or like cheat codes in a video game. It's like, okay, I got the result that I wanted, but I don't feel that good about it. And that's like, it sucks. Like, I want to feel good about solving these, but it's okay. You know, you start, we'll see if I remembered anything from yesterday. That'll be the first step towards if I actually was paying attention to anything yesterday. But what are you gonna do, eh? Okay. So let's just start. I think it's just, there's a couple questions. So, brother, keep doing your thing. Have a good time. I'll catch up later. All right, man. Stop by anytime. I'm trying to do streaming every day, every Monday through Friday, 3 to 5. That's kind of my goal right now, is to get back into a schedule of doing it. If I can convince myself to do this for 2 months, I feel like I'll be in a path to never stopping doing it. But we'll see how that goes. All right. So, this is an implementation. So that's what we had. That's actually what we wrote yesterday. This kind of stuff always throws me when I'm learning something new in coding. It's like, in my brain, even though it doesn't know the answer, it'll just be like, oh, there should be a better way than 3 while loops. And there might be, but I get stuck on like, oh, there's got to be a better way. I should figure out that better way instead of just like trying to implement it. So today I'm going to try to really focus on like, I'm just going to implement it, not get caught up on the fact that I might not know what's happening. We'll see. We'll see. We falter. It's part of being human. Have you checked Prime's algorithm course? I haven't yet. Is that the one on is it on boot.dev, or is that the one? It's the one is it Front End Masters? That one? I know I've seen a couple of his courses. But I started watching it. Okay, yeah, Front End Masters. I got to go back and watch it cuz like I started, but then I just couldn't stick with it cuz I was busy and wasn't paying attention, and I need to go back and do it though. Cuz was it good? Have you done it? Yeah. I believe it. He's got a great... I consider him and I like polar opposites in the fact that as far as like streamers go, in the sense he knows so much and is really good at explaining it. And the whole reason that I started streaming was I just wanted to be the person that was like, I literally don't know what I'm doing, and I'm just gonna try stuff, and you can come follow along with what it's like to be not good at something. and maybe you'll figure it out. But like, Prime has all this amazing knowledge in his back pocket and has been doing it for a long time, and he's ridiculously smart. And when it comes to coding and lots of other things, I don't know what I'm doing, and I forget what I'm doing a lot of the time, and just kind of make it up as I go. And that's just what I do. That's my style, you know. I made a comment the other day, and it's very much the truth. It's like my wife is like a huge planner, and I am like not a planner at all. And because I know if I sit down to plan, I'll get the plan done, and I will feel so accomplished with the plan that I won't start the work. And so it's like, I would rather drive back and forth to the store 5 times to go get items that I realized I missed as I'm doing the thing than spend an hour planning out and going through and figuring out everything I need. Because I know if I like sit down and spend the time doing the plan, by the time I'm done doing the plan, I'm like, all right, I'm good. That's basically doing it. I mean, I feel like I basically accomplished it, so why bother? And then I'm just done. I just don't feel like doing anything anymore. So, you know, I gotta jump in. I'm a jumper. You know, when your parents are like, if everyone jumped off the bridge, would you? It's like, yeah, probably. I probably just would. All right, so that's our merge sort algorithm. That is a merge sort. Look at that. And on the big O complexity chart, oh, this is all we're doing. Oh, what is merge sort's big O complexity? Okay, do I remember this from yesterday? I believe merge sort had, oh gosh, I believe, dang it. Okay, let's see if I can think through this. So I could just go back and read it, but depending on the size of the list, it's an NM, isn't it? So is merge sort I want to say merge sort is merge sort O of N or O of N log N? It does get slower as you add more things to it. Damn it. One day of being away and I already forgot. Hold on. I'm going to go look it up. That's how let's see if I can find it by looking it up. Is it in here? No. Let's go back again. Oh, now we're back into bubble sort. Darn it. Okay, so it's... What is bubble sort again? That might help me. Bubble sort is at best N, at worst N squared. Okay. So I think for some reason something about merge sort being ONM is something I remember, but that's not an option. So is ONM just ON? I'm gonna do it. I'm gonna guess. Darn it. Dang it. Is it ON log N? This was my second choice. I'm gonna guess all of them. How many more armors do I have? Should I buy some armor so I don't I don't waste my streak? I haven't done this in a long time. I should be accepting quests. Man, I forgot about all this. XP potions. I haven't been doing any of this stuff. 0 of 2 embers. Oh yeah, those are like your streak freezes. Whoops. I kind of forgot about all this stuff. 41 sprees. Where do you buy stuff? Oh, in here. Shop. How many armors? Oh, I'm almost out of armors. I better buy some. I only have 9 gems. What have I been doing with all my gems? Yeah, I never use these seer stones. I'm going to sell both of them. I'm going to buy one more armor. Okay. Now we can guess again. Is it this one? Yes! Okay, it was my second choice. That's not bad. I need to explain it, though, because I don't remember. I don't remember why it's that one. Okay. So... The complexity of merge sort being O n log n comes from looking at two distinct parts of the algorithm: how many times we split the data and how much work we do to put it back together. The logarithmic part, log n, in the merge sort function, we recursively split the list in half. Every time we divide the input size by 2, we are performing a logarithmic number of operations. If you have 8 items, you split them into 4 and then 2 and then 1. That took 3 steps. In mathematics, 2 to the power of 3 equals 8 is the same as saying log 2 of 8. This isn't where I parked my car. Rick, what's up, man? Welcome, welcome. We are here. Oh yeah, I forgot to put out a tweet that said I'm actually live. I should probably do that. Whoops. I always forget that then. Let's do that. We are doing more sorting. Hold on, I'm just putting this tweet up. X Gang. Oh no, Rick's everywhere. The only downside with X Gang is you don't show up on stream. I don't know how to do that yet. I don't know how to put that chat up on stream. I don't think you can. Or if you can, I haven't figured it out. Alright, so... almost there, almost there. Just typing. Typing as fast as a man can type. Not really. I can't spell anything to save my life right now. Okay. So, Rick, we were just reading about... XD's up their game for sure. Yeah, I agree. They do a terrible job. We were just reading about... I picked Merge Sort's Big O complexity. Full disclosure, I got it on my second try because I couldn't remember. I was pretty confident that my first guess wasn't right, but I wasn't confident enough to know that my second guess is what I should have gone with first. So now I was just getting... I wanted to get the explanation from Boots. So, every time we already read that. The splitting phase represents the log n portion of complexity. That makes sense. The linear part, once the lists are split down to single elements, the merge function starts combining them back together. While I is less than the length of first and j is less than the length of second. Inside merge, we have to look at every single element in both lists exactly once to decide which one goes next into the final list. If the total number of elements across both lists is n, the work done to merge them is linear, or O of n. Putting it together, since we have to perform O n merge operation at every level of the split tree, and there are log n levels in that tree, we multiply them together. Okay. So there you go. So you get O n log n. This is significantly more efficient than quadratic algorithms like bubble sort, O of n squared, because while n grows, log n grows very slowly, keeping the total operations manageable even for large data sets. Okay, so there we go. Now we know. Good old merge sort. Thanks, merge sort. That's very helpful. Thanks for being a faster algorithm. Okay, what's next? Boom. Oh, did I press the wrong button? I'm on the wrong screen. Boom. Why merge sort? Pros, fast. Merge sort is much faster than bubble sort. We just learned why. It's stable. Merge sort is a stable sort, which means that values with duplicate keys in the original list will be in the same order in the sorted list. I don't know what that means. Like, I mean, I get what that means, but why is that... Why is that good? Does anybody know? I could read this stable sort post, obviously, but... We're going to read it. Stable sorting algorithms maintain the relative order of records with equal keys. The values remain in their original order if the keys are equal. That is, a sorting algorithm is stable if whenever there are two records, R and S, with the same key, and with R appearing before S in the original list, R will appear before S in the sorted list. Okay, well, that doesn't help me. Ryan, what's up, man? Thanks for following. Appreciate it. Okay, so that didn't really help. Like, why is that beneficial? Is it just faster? Is that why? I don't really know. If anyone knows, chime in. Cons of merge sort. Memory usage. Most sorting algorithms can be performed using a single copy of the original array. Merge sort requires extra sub-arrays in memory. Recursive. Merge sort requires many recursive function calls, and in many languages, like Python, this can incur a performance penalty. Okay? Yes, and these are all the whiles and ifs, and gotta love it. Okay. When might merge sort be a good idea? Need a simple sorting algorithm for a small data set that can be written quickly? Need a fast sorting algorithm and memory isn't an issue? 1 or 2? I know my vote. 3. No. It is good old numero 2. Right? 2? 2? I'm putting 2. Hey! Oh, Rick, thanks for following, dog. Appreciate it, man. I hope you're having fun. We're here to learn, baby. This is when you realize that when I go to those events like Omicron, I really am unknowing of what I'm doing. I just like this stuff. It's fun. But I'm still quite terrible at it. All right. So which function is recursive? The merge sort or the merge part? Well, we already read that in the last one. And the recursive part is the merge sort. Yeah. Crushing it, baby. That's what I'm talking about. Okay. I get paid to do this stuff, and I don't know what you're doing. Nice. We're sorting, baby. We're doing those sorts. You know what's funny is, like, I do think that the algorithms part, I know you can obviously get away with doing a lot of coding and not touch algorithms, but I was always interested by it. And so I wasn't sure which course I wanted to get back into, and I saw that they had this algorithms course, and I was like, perfect, because my other plan for streaming was to just read this book for everybody. And I thought it might help too with my understanding of speed and algorithms and all sorts of fun stuff. But then I looked at it and I was like, oh, this isn't actually what I want to learn right now. But it will be fun. I'm excited. I think I do have some algorithm book back here somewhere. This is what you call turning away from the audience. Oh yeah, I have a few algorithms books. Anyways, we'll read those at some point too. Oh, actually, I have a specific algorithm book that I really want to read. It's coming. Data structures was my jam. That is what unlocked my brain. Could also try a hot tub stream. That's what they were doing last time I was on Twitch. I mean, that does sound like a pretty good idea. I'm not against it. Let's just say that. You know what? So I've told this story many times, but too bad you guys are in here, so you're stuck with me. The thing that unlocked development for me, like my whole life, I've always really liked computers. I've always been reasonably technical. So I've always done lots of goofing around with computers and like trying to make Python codes and like copying code from other things and seeing if I can understand it. And I was never very good at it, but I always enjoyed it. And then in 2019, I think, or 2018, I came across the Pico 8 fantasy console. which if you play any games, you might recognize the game Celeste was originally coded in Pico 8, and then I think they rebuilt it in Love 2D before they released it. But here, I'm just gonna pull it up. The Pico 8 is awesome, and because it's this whole development environment with awesome constraints. So like you have a limited amount of memory that you can use. You can here, I'll just actually open it up. You can build hold on, I'm just opening it. I'm gonna put it up in a second. Oh, my computer's struggling right now. Struggling. Oh, how many times did I just open this? Like 12? But it's all included in. Oh my gosh, I did open it a bunch of times. Hold on, sorry. Here, let's do this. There. Okay. So this is Pico 8, and it's this fantasy console where everything is built in. So like you can start right away and just go straight into coding. Here's your thing. You have a limited amount of memory. But then what I really always loved about it is there's also your sprite editor built right in. There's your map editor built right in. You can do sound effects. Like, do I have the sound on for this? Can anyone hear that? I don't know. I don't know how loud that is compared to the music. Maybe if here, I'm going to turn this up pretty loud. But like, and then you can just, go like this. Or you can change it to this one. And you can do anyways, it's awesome. And so it's all this stuff built in. And then the last one is like all of music. And you can actually set together some wild music. All of this to say, the reason that I brought any of this up was that this is what unlocked coding for me. When I got in here and I was able to start making games, and it was as easy as like, you start with this, and it's just in Lua. So it's like super easy. What is it? Update 60 for 60 frames a second. And draw. And then you can just, like, you don't even need this, but you can if you want it. And here, we'll do this. X equals 50. Y equals 50. Update if button. I think it's 0 is left. 0. Then X minus equals 5. End. Draw. This is when you should actually clear the screen. And we need to draw a circle. Well, what's circle? Circfill, I think. Circfill, X, Y, radius, I believe is the next one. And color, I think is how it goes. Anyways. Oh yeah, there. And I only made it move left, but like, I need it to move right so I can bring it back. Just like doing this, all of a sudden it's like, oh, I can just like make stuff and it works. Like, this is amazing. It does what I want. Like, if I change a number, I can just like see it on the screen. And because it was all contained in this one environment, it got me past all the shit of like setting up a Python environment or like an IDE that I didn't really care about at the time and like didn't understand enough. And it was just like, I could just do this and then I could build something and it would work. And it's like, I built a bunch of games, and they were so much fun, but it was really, this was the thing that made me go, oh, I could do stuff in development. Like, I can code things. Like, I don't know a lot about coding, but like, I can do it now. And it was a huge game changer for me. So that was a really long-winded story. But I am like, I feel very indebted to the guy who created it. His handle's called Lexalawful. But like, I feel very indebted to him because without this mentality of what he built, I don't know if I ever would have got past the starting and stopping of doing, trying to do the same Hello World app in 12 different languages because nothing was clicking. And this clicked for me. And I was like, okay, I'm into this. Okay, let me see if I can show you one of the games I made. It is super cool. And it's like $10. You can go buy it on his website for like $10. It's awesome. There's a great community. This is like a, not even a humble brag, but just a cool thing. Like through Pico 8 and their Discord, I got to talk to Tom Hall like a bunch. Like I've had many conversations with him now, who's one of the co-creators of Doom. Like just weirdly cool niche of people from all over development who are, some are like super duper talented. But yeah, this was, the long story short of that is this was my like light bulb moment of, oh, I could actually maybe do some of this stuff. Here, I'll show you Aaron's quest. This one's fun. Oops, I keep forgetting LA is not a thing in here. Load Aaron's quest. Load. Okay, check this out. This was a game that I made. I won't play the whole thing. But this was a game that I made for my nephew when he had his birthday. Can you? Hold on. Why can't I hear that? Can you hear the Pico 8? It should be playing music. Why can't I hear it? Oh, because my volume's down low. Someone hacked my MSN chat room in 2002. I'm on a path of revenge. Learning to program was necessary. That's amazing. I absolutely love that. Yeah, so this was a game that I made for my nephew. And the cool thing was, after he found the 16 scrolls, they unlocked a passcode for a Nintendo eShop gift card. But yeah, so anyways, this was the game, and like it was a lot of fun. Oops. And I had a lot of fun making it, and it was pretty cool. And you can do lots of fun stuff. And there's magic scrolls, and you can play this online for free if you want to. And there's caves and secrets and all sorts of fun stuff. So anyways, like I said, I won't play the whole thing, but if you go through the whole game, then you will unlock this code. You get all the code, and it plays a happy birthday song, and he got a $50 gift certificate or something. And anyways, so that was my foray into like, I can code. Coding's fun. I can make things. This is cool. I should do more of this. and that's what it was. And I took way longer to talk about that than I planned, but that's okay. It was a lot of fun. I love the revenge. Did you end up getting revenge on your path of revenge? Did you make it? Did you make them feel terrible about them hacking your MSN chat? Oh yeah. Nice. That's awesome. That's awesome. Oh, I need to change this scene back to this one where I'm not so big. I chased them through the IRC pit of hell and eventually trapped them. That's awesome. Was it just some rando, or was it like somebody you knew, or how did what was the end of that story? That's awesome though. That's super cool. Nothing like spite and revenge to get you started on something. It really is powerful. You know, it really is powerful. Oh, excuse me. It's a long one. We'll tell it one day. All right, cool. One day you can come on. I'll have you on stream and you can talk with me about it. That'd be fun. Okay. We're going back to insertion sort. We're on to a new one. Oh boy. How many more of this sorting algorithms class? Oh man, this is wild. I feel like I got like 2 more days of streams based on just me trying to get through these. So let's do insertion sort. I've got my music off. That's fine because we're going to watch this video. Insertion sort builds a sorted list one item at a time. It's much less efficient on large lists than merge sort because it's O(n) squared, but it's actually faster, not in big O terms, but due to smaller constants than merge sort on small lists. Ah, okay. Let's hear what Lane has to say.
first, let me talk about when and why you would actually use insertion sort, and then I'll break down the algorithm step by step. Insertion sort is interesting because it's actually really slow in the average case, order n squared. But it has a niche use case where it's actually used in the real world because of how fast it is. And that's when the data is already mostly sorted and when the data set is very small. Some sorting libraries will actually use insertion sort when the data set is small enough and fall back to a different algorithm on larger sets. So how does it work? Well, it's actually one of the simpler algorithms. We start with an unsorted list of numbers. We'll iterate over each index or each position from left to right, and we're going to keep track of two indexes, I and j. I will be the index of the current number that we are on, and j will start at that same position, but it'll actually move to the left. I'll show you in a second. Now, because it's a look back algorithm, we can actually skip the first index. We'll set I and j equal to position 1 or index 1, which is of course the second position. Now the number doing the swapping will be the number at j.
That was a big mess up for me with starting really getting into programming with Lua, because they're one based array. So everything starts at 1. So remembering to always have to go back to 0 for everything else took me a while. I feel like most people have the opposite feeling with Lua, and they hate it because it's a 1 based index, and so they always forget. But for me, it was so much easier. I was like, this makes total sense. And then switching to 0 base was like, oh no, what am I doing with my life?
And the number at 1 less than j. I actually has nothing to
Unfortunately, my headphones are broken today because of my naughty cat, so I can't hear your voice. It'd be great if you could reply to me via chat. Everything is 1 ahead of the array index. You're 1 ahead of the array index, Emmett. What's up, Olavia? Here you go. Here's your text chat. I'm not going to be able to do this a lot. I also put it on YouTube for some reason. Emmett, my man. How have you been? Everything is 1 ahead of the array index. I mean, I get it now. Professional streamer. No, not even close. Don't even try with that. I'm nowhere close to professional. Do I play League of Legends? Olavia, I do appreciate the chatting, but I don't know if I can do a lot of typing here. I do not. What if I just did this? What if I do mime? No. How does that work? Wait, I can be a professional. Look, I can take it off YouTube. I do not, unfortunately. And I appreciate the chatting. I gotta actually write this up. Chatting. But I don't know how much typing I can do. Oh my gosh, I can't spell. Why am I so bad? 0 time for games. Too busy streaming. That's right. I mean, I could stream games. I have done that a few times. Gotta learn insertion sort, baby. No. I can. Rick will speak for me from now on. Okay, there you go. Rick. Rick is my chat translator. I love it. It's perfect. Okay, we're turning on the music. Oh no, wait, we got to finish this video first.
With the
League of Legends is a cursed game.
Our place in the algorithm.
I am from Canada. Hold on, though. We're gonna watch this video. I know you can't hear it.
Position j minus 1, and if they're out of order, we're going to swap them and decrement j. If they're already in order, then we can just move on and increment I. And whenever we increment I, we also move j back up to where I is. It seems really fast at first because I and j are close to the start of the list, so the amount of backtracking j has to do isn't very much. But you'll notice as I and j get larger and larger, we're gonna have to look.
Hold on, Emmett. I'm trying to learn about insertion sort. You can't be coming on to me in the chat, all right? I mean, I appreciate it, but I can't focus with that kind of language in here.
Back through more and more of the list.
Oh, sorry. I don't think Olavia caught it. Olavia, I'm gonna message Rick. Rick is typing what I am saying for you. I'm trying to learn Don't Come On To Me Without Paying. Oh Jesus. This is going to be amazing. All right, I'm finishing this video.
Sped up version looks like on mostly sorted data.
This isn't the After Dark? No, not yet. Not yet. I should do an After Dark. Actually, so my my wife and kids are out of town this weekend, so I was thinking about maybe doing a like long Saturday stream, or maybe tomorrow night doing one. We'll see. We will see.
What it would look like on completely random data.
Rick, I appreciate you helping out here.
And here you can watch it be really slow on reverse sorted data.
That is pretty slow. Okay. Let's do our assignment. Rick is the best. Rick is a very cool guy. It was nice to meet Rick in New York. Totally randomly, and I appreciated it. It was nice. We didn't get to spend too much time together, but that whole day was a bit of a blur to me. It was a lot of fun, but my goodness. All right, here's our assignment. Our influencers want to sort... Oh yeah, for anybody who hasn't been following along, this course is based on the idea that we're building this thing called Locked In, and it's LinkedIn for influencers, sort of. Our influencers want to sort their... I don't know who types worse, you or me. I don't know either, man. Our influencers want to sort their affiliate deals by revenue. None of our users have more than a couple hundred affiliate deals, so we don't need an n log n algorithm like merge sort. In fact, insertion sort can be faster than merge sort and uses less of our server's memory. Complete the insertion sort function according to the given pseudocode. Okay, so what we're going to turn into code is for each index in the input list, starting with the second element. Sorry, I caught Reed's text on screen. That's fantastic. Set for each index in the input list, starting with the second element, set a j variable to the current index while j is greater than 0 and the element at index j minus 1. Oh my gosh, excuse me. I can't keep this up. I'm killing myself. You got to keep going, man. Let's go. I get it. I get it. I'm glad you clarified, though, for the audience. It's greater than the element at index j. 1. Swap the elements at indices j and j minus 1. Decrement j by 1. Return the list. Should we read the tip? I like reading the tips. In some languages, you need to use a temp variable to swap values, but in Python, you can do that in a single line. Oh, Python, you're so silly. Okay, so let's try and turn that pseudocode. Thoughtless does like the tip. Son of a gun. I don't even know. It's so funny. I don't even know if anybody's still in here. It would be hilarious if everybody left the stream and you are just typing all of the stream and nobody's here. That would be incredible to me. All right, so let's keep going. We're doing great. We're doing wonderful. Everybody's having fun. So they're going to try and implement this pseudocode. So first we need to set I equal to... Do I need to... Actually, wait. Do I need to set these right away? Hold on. We're just going to try and follow the whole thing. So for each index in the input list, starting with the second element. So for j... Oh, gosh. What am I doing? I'm already confused myself because I'm having too much fun. I'm having too much fun, and I'm not paying attention. I'm going back into this.
Niche
Hold on.
Case, it'll actually move track of 2.
I also
swap.
realized
Just kind of
I
keep it-
need
we'll
my
skip the
music.
first index.
That's the problem. That's the real problem. There we go. Okay, now we're ready. All right, for each index in the input list, starting with the second element. So for I in nums range 1 nums. I think this is right. Oh, that music is bumping, baby. Set j variable to the j equals I. Right? Or does that have to be nums I? No, I think I can just do that, right? Then we're gonna do, whoops, while j is greater than 0. What is that? Is that a flame? Okay, while j is greater than 0 and element at index j minus 1. So wait. Element. I hate pseudocode. And the element at index j minus 1 is greater. So wait, j minus 1 is greater than j? And the element at index j minus 1. Do I have to put these in nums? Do I need to be doing this? I can't remember how this works. I feel like I'm supposed to be doing that, so I'm gonna do it. Let's see what happens. Okay, swap the elements at indices j and j minus 1. And that's the whole thing that he said. Oh, wait. Does this need to be nums I? I might be messing this up completely, and that's okay. Swap the elements at index. So nums. How is it like that? Nums j minus 1 equals nums j minus 1 nums j. Is that what it wants? And then decrement j by 1, j minus equals 1, and then at the end we return nums. Is that right? How are we feeling? How does everybody feel about what I just did? Is that, are we feeling good? Are we feeling like maybe I did it? I guess we'll find out. I'm terrified, personally. I have no idea. Oops, I also just lost my screen. You did it? Did I really? No! Didn't do it. I messed something up. I messed something stupid up. Oh, table list object cannot be interpreted as an integer. Oh, duh. I need to do length of nums. Okay, that's not bad, though. If that's all I messed up, man. No. Darn it. List index out of range. Ah! Okay. Oh, wait. Does this need to be nums j? No. Does it? I don't know. We're just gonna keep trying things. No, I'm messing up something. Hold on. And the element at index j minus 1 is greater than the element at index j. So it's greater than 0. And j, is it j? No, that can't be right. What did I do wrong? Hold on. What happens if I do this? Print j. I just want to see what's printing. Show me. 3. Okay, so that's good. So that's the right element, 3. And then, well, nums j. Or do I need to do no? Oh, wait. Does this just need to be this? I'm going to try that. Oh, okay. Okay. Hold on. Hold on. Hold on. We're making progress. So what did I mess up here? Let's see. I did 4, 3, 2, 1. I didn't change anything. Nothing moved. Awesome. Okay. So it ran through. That's good. It just, nothing changed. What did I mess up? While J is greater than 0. It is going, oh wait, okay, hold on. Does this need to be just like that? No, shit. Okay, but this is good. 1, 2, 3. Right? Oh, fart. I blew it. I minus 1? Wait. But where did it say to I minus 1? Yeah, hold on. Hold up. Hold up. Well, J is greater than 0. And element... Maybe, I don't know, just toss no ideas, no clue. That's okay, I don't know either, so that's fine. And the element at index J minus 1. Is it this? Okay, wait, does this one need to be like this? What happens here? Oh! We're close. We're close. Does this need to be... Does this one need to be nums J? Dude, we're close. We're close. Yeah! Okay, I just misunderstood the elements part in the pseudocode. We got there, Rick. We got there. It was just because we needed to... We were using J greater than 0, and I needed the element of J minus 1 being greater than nums of J. Now let's... Okay, now I got a little too cocky and felt like I already solved it, but now we're going to submit it, and that's when the little edge cases that I didn't pay attention to or think about break on me. So let's find out. Come on, baby. Come on, baby. Oh! Who even needs AI? What even is Claude? Could Claude even do this? Yeah, hey, you know what? I minus 1 definitely helped. It made me think of the right answer. So there you go. It was perfect. Ah, we got there. That's all that matters. Oh, I also don't need this print anymore. Print debugging. Okay, now I always like to look at the solution just to see if I did the same thing. Pretty close. What did they do differently? Oh, it's just because, yeah, they always like to do these. Not that this matters, but they always like to add the little spaces. Whoops. Ah. There. Not that that matters, but hey, we did it. Good job. About to write Python professionally for the first time soon. Not looking forward to it. Hey, man, I will say this. If you need a quick refresher, do the boot.dev Python course. It was awesome. I just did it like a year ago and forgot 99% of it. I mean, hey, you gotta just do it for money. It's part of life. It's part of life. Unfortunately. I'm pretty certain that I was born to be like a live in the middle. Okay, I have a weird dichotomy. I am a live in the middle of the forest person, but also not a huge bug person. So I don't know how to make that work. I haven't been able to figure that out. So I don't really like or care or worry too much about making a lot of money, even though I would happily take like $1 billion if somebody wanted to give it to me. But I also am not a big fan of bugs. So, you know, balance. All right, insertion, big O sort. I draw the line at Java. Won't do that for money? I bet you would. Come on, Rick. Don't lie to me. We all know you would. we know you'd sell out for the right number for some little bit of Java. Little Java never hurt anyone. Little Java never hurt anyone, you know? My kids better be starving. I mean, hey. You might have to do it. Okay, I'm continuing on, Rick. We're gonna go through some more insertion. Insertion sort has a big O of O to the n squared. Because that is its worst case complexity. The outer loop of insertion sort always executes n times, while the inner loop depends on the input. Best case, if the data is pre-sorted, insertion sort becomes really fast. Can you see why? So if the data is pre-sorted, insertion sort becomes really fast because the inner loop will only need to run a small amount of times because it's pre-sorted. Or technically, if it's fully pre-sorted, it would run one time. Right? Average case. The average case is O(n) squared because the inner loop will execute about half the time. The worst case, if the data is in reverse order, it's still O(n) squared and the inner loop will execute every time. So it's O(n) squared, but just gets way higher. My trolling usually works better if you have stronger opinions. Oh, I'm sorry. I don't know what to tell you. I'm like... it's legitimately my least useful feature in real life. It's that I am very adaptable. It seems like it would be a good thing, but it means even if something is annoying me, or I can get over it so fast that I just don't even have time to think of it doesn't bother me long enough to drive a solution. So I just I go, well, whatever. Yeah, that's not a big deal. I'm over it. I should get stronger opinions. Maybe one day. What is insertion sort's big O complexity? O(n) squared. This is a good song, too. Now everyone has just collectively decided to hate Rust so we can all get along. Perfect. All right. I'll hate Rust, too. Although I did have fun doing the Rust, what is it? The manual or whatever? I started doing that a while back. That was fun. What is insertion sort's big O complexity on an already sorted array? It is O of n? We just read this. I think it said O of n, right? Oh no, it's O log n. Right? Shoot. What was it when it was already started? I'm going back. I'm reading. Where did we read it? Yeah, it was O(n) log n. No, wait. That's merge sort. Darn it. Where did I read it? I know I read it. Well, I'm going with... Oh, wait, we already answered this one. I'm going to say because O(n) is faster than... It's either going to be this one or O(n) log n. Let's go with this one. Whoa! Yeah! That's what I'm talking about. Okay. We're actually moving along pretty quickly. I might get this whole lesson done today. Oh, maybe not. I got a little eager. Overeager. Why use insertion sort? Fast. For small data sets, even faster than merge sort and quick sort, which we'll cover later. Adaptive, faster for partially sorted data sets. Stable, does not change the relative order of elements with equal keys. In place, only requires a constant amount of memory. In line, can sort a list as it receives it. Why is insertion sort fast for small lists? Many production sorting implementations use insertion sort for very small. Oof, that'll be interesting. Sorry, I just got an alert. Microsoft reported $4.27. Oh my gosh, dude! All these, I didn't realize it was 4 o'clock. What? So Meta just came through. They crushed their earnings. Let me guess. Did their stock shoot up? What? Wait, did I read that wrong? Did they blow their earnings? What did that alert just say? I could have sworn that alert just said they crushed it, and that but then it still dropped. Microsoft reported $4.27 earnings per share, and their estimate was $4.07. So what's their stock doing? They're going up, but Meta is going down. That's so funny. But I could have sworn I read that alert properly. Where's the data? Wait, I need the earnings report. What was it? Yeah, that's wild. Okay, not that I care that much, because I'm pretty sure I have nothing in these, but Meta crushed their earnings like a huge amount, and their stock is cratering right now in after hours. And then Microsoft, who just barely beat their earnings, it still did, their stock is flying up 3%. Wild, man. Who knows what even happens? What even is all this stuff anyways? Okay. Many production sorting implementations use insertion sort for very small inputs under a certain threshold, very small like 10ish, and switch to something like quick sort for larger inputs. They use insertion sort because there's no recursion overhead, it has a tiny memory footprint, it's stable, it's a stable sort as described above. Nice, okay. Is insertion sort useful in production systems? Yes, but only on very small inputs. There we go. Easy peas, lemon squeeze. And which algorithm uses less money and which is generally faster on larger inputs? So that's going to be insertion, merge. Dude, we are learning. Yeah, hey, thanks, Rick. I usually try to do it until around 5, but if not, I'll be back tomorrow as well. So thank you for stopping by and thank you for translating for me. That was a lot of fun. We'll see. We'll see what happens. Have a good one, man. All right. We're going to keep going. Although I might have to do a quick bathroom break. Let's get through. Are we done with insertion sort? Is that it? That's it. We're on to quick sort. Okay. Bathroom break, then quick sort. Let's mute. We are back. Sorry about that. Just a quick break. Is the same type of code level we have right during job time? I mean, this is like, these algorithms are definitely algorithms that you would write in your work. Probably more complex. This is just learning. I am a hobby developer. I've always enjoyed doing it for fun. And so keep letting my skills atrophy by never using them. So I do some boot.dev to try and fill in the gaps and hopefully learn some more stuff. And yeah, mostly just have fun and show people that you can stream and be an idiot and still learn how to do something fun. You can. I'm the guy who's here to show you that literally anybody can learn how to code. You know, if you just keep at it long enough. We're just about to start quicksort, so that's what I was about to do. I just had to do a quick bathroom break, grab some water, and then we're gonna keep going. We're gonna move into quicksort. Hold on one second though. Just need to check a couple things, make sure these things are working. All right. But thanks for stopping by. Do you do coding already for your work, or are you just learning? Oh, this is weird. I just realized somebody else was chatting in, and I missed it. It didn't come through. That's annoying. Josh, I don't know if you're still here, but your messages for some reason didn't show up, and I apologize because I did not see them. And did they come up in here and they got... Oh, I turned off YouTube accidentally. I'm sorry, Josh. I don't know if you're still in here, man, but if you are, I apologize. Yeah, that is fun. Actually, I don't know if they did come through here. That's so weird. Interesting. Well, I don't know why they didn't show up. Maybe something got messed up in here? Sorry, now I'm just on a little bit of an investigation streak. Seeing if I can figure out why. Are you actually... No, you're not muted or anything. I don't know. I apologize, dude. But if you come back, hopefully I can figure out how to make it show. But yeah, Play with Data. Are you, do you do coding for anything? Well, we are going to do quicksort. And that's next on the old list. Okay. Sure. Hold up. Almost there. Oh, now it's cratering. Who even knows? Who even knows what goes on in this world? Alright, sorry. Okay. We're back. Okay, quicksort is an efficient sorting algorithm that's widely used in production sorting implementations. Like merge sort, quicksort is a recursive divide and conquer algorithm. Okay. Divide. Select a pivot element that will preferably end up close to the center of the sorted pack. Move everything into the greater than or less than side of the pivot. The pivot is now in its final position. Recursively repeat the operation on both sides of the pivot. The array is sorted after all elements have been through the pivot operation. Okay. Let's check out this video from Mr. Wagner. Turn off the old tunes.
Quicksort is fast and efficient, and unlike some of the other algorithms that we've covered on this channel, it's actually used in the real world. Looking at you, BubbleSort. Quicksort is a divide and conquer algorithm, just like merge sort. And while it technically has the same big O complexity as merge sort, order n log n, it doesn't require so much memory, and it doesn't have to copy elements from sublist to sublist. It actually sorts the entire list in place, which means that it can be more performant. All right, let's dive into how it works. We'll start with a random list of numbers. The first thing we need for quicksort is a pivot number, and to keep things simple, we'll just arbitrarily use the element at the end of the list. In this case, 5. Next, we need 2 pointers, I and j, to keep track of things as we're going to be swapping them around. I will start at index -1, which of course isn't a real index, but we need to be able to increment into index 0 on the first swap. Then j will start at index 0, which is 8. So in this case, we'll be comparing 8 and 5. And because 8 is not less than 5, meaning j is not less than the pivot, we don't move I, but we do increment j. Now we do it again. We compare j to the pivot, 3 to 5, and because this time j is less than the pivot, we increment I, then we swap I and j. Now I understand that it's a bit funky. We're comparing j and the pivot, but actually swapping I and j. Just remember that. All right, and now we just do it again. So now we'll compare j to the pivot again, in this case 2 and 5. And again, because j is less than the pivot, we increment I, and then we swap I and j. Next, we compare 9 and 5. Now this time j is greater than the pivot, so no swaps. We move j forward, but we do not move I forward.
That's
1
actually
is less
really
than
cool
5,
to see.
So we move I up, and we swap I and j. 7 is greater than 5, so no swaps here. 6 is also greater than 5, again.
And then 5's
10
just
is
going to end
greater
up
than
going...
5, 4 is less than 5, one last swap. All of the numbers at or to the left of I are smaller than the pivot, and all of the numbers to the right of I are greater than the pivot. If we swap I plus 1 with the pivot now, then the pivot will be in its perfectly sorted place. Now, that's just one round of the partition function in quicksort, but frankly, it's the interesting part. The way we turn this partition function into a full-blown quicksort is by recursively calling this partition function. So we'll continuously partition, do this algorithm, over and over on each half of the list until the full list is sorted. Now, remember how I mentioned that quicksort is generally more performant than merge sort? That's true, but it does have a dark side. If we consistently pick the smallest or largest element from the list as the pivot, it gets really slow and will actually degenerate into order n squared in Big O terms, which effectively makes it a bubble sort equivalent, which is something that no sorting algorithm wants to be.
Interesting.
But honestly, that shouldn't scare you. There's pretty trivial ways to make sure that quicksort never degrades. For example, we can just check and make sure that the list isn't pre-sorted. We could randomize the list before sorting it, or we could even pick the pivot at random for maximum chaos. Anyways, optimized versions of quicksort are used all over the place in the real world. Most languages' standard libraries actually do use quicksort, at least for part of the standard implementation of their sorting algorithms. Now, so you can properly visualize it end to end, here's a full animation of quicksort on a larger data set.
Yeah.
And here's another full animation, but where the list is already sorted and the performance degrades. You'll notice that it's a lot slower.
Oh, yeah. Interesting. That's really cool. I love these. I say this every time, but I love these charts. They're so cool. They're really, really awesome. Okay. So let's read through our pseudocode, and then we'll try and do the assignment. And we're cruising. We are cruising today. Hold on. I'm just checking one thing. My B. All right, hold on. Hold up. Hold up. Yeah. Okay. Perfect. That's all I needed to see. Fantastico. Okay, let's see if we can implement this pseudocode. Well, first let's read it. So select a pivot element. Will arbitrarily choose the last element in the list, move through all the elements in the list, and swap them around until all the numbers less than the pivot are on the left and the numbers greater than the pivot are on the right. Move the pivot between the two sections where it belongs. recursively repeat for both sections. That's the only one I'm not 100% sure. Oh no, because to move the pivot, you swap where you are at I with the pivot number. That was how they did it. Okay, I can remember that. Assignment. We now have 2 sorting algorithms on our locked-in backend. It is a bit annoying to maintain both in the code base. Quicksort is fast on large data sets, just like merge sort, but is also lighter in memory usage. Let's use Quicksort for both follower count and influencer revenue sorting. Complete the quicksort and partition functions according to the given algorithms. Okay, so the process is started with quicksort A 0, length of A minus 1. Woof. All right. Complete the quicksort nums low high. If low, okay, so let's just see if we'll just try and go through this whole thing and follow along. So if low is less than high, then partition the input list using the partition function and store the returned middle index. So middle equals partition of nums low high. Then recursively call quicksort on the elements left of the pivot. So that is quicksort of low to, oh, hold on. Quicksort of, what's the best way to do this? Nums low to middle minus 1. Is that right? That seems wrong. That's fine. And then we'll do quicksort middle, quicksort nums middle negative 1, or middle plus 1 to high. That seems wrong. I mean, I did spell high wrong, so it's definitely wrong, at least a little bit. But that still seems wrong. So now let's do the partition point. And let's see if we can figure this part out. Okie dokes. Alrighty. So we have partition nums low high. So set the pivot to the element at index high. So pivot equals high. Oh, I'm an idiot. I have to do this, don't I? That's what I need to be doing. Don't I? Do I? Let's find out. To the element at index high. Yes, because that is an index. Boo. So let me actually make sure. Partition the input. And also low is greater than high. Oh my gosh, do I even know how to read? Not really. All right, let's just keep going. Set I to the index before low. So I equals nums low minus 1. Then for j in range low high, do if the element at index j, so nums j is less than pivot, then we do I plus equals 1. And we swap the element at index I with the element at index j. So we can do nums I nums j equals nums j nums I. Then we swap the element at index I plus 1 with the element at index high. So we need to do swap the element at so nums I plus 1 nums high index high, the pivot's position equals nums. Hey, what's going on? How you doing, man? We're learning quicksort. I'm not sure how much I've messed this up, but we're gonna find out. We're going for it. We're working on it. We're working on it. A and DS, baby. Let's do it. I think I know I messed up the quicksort part, but I'm gonna go back after. First, I'm just gonna try and finish this part and see what happens when we run it. That's my favorite way to debug, is run and see what the heck happens. Forgot some music. I'm sure I would know if you were doing it wrong. I'm not sure you would know. Well, that's the best case, you know? That's why I do this, though, because I don't know what I'm doing. I just like to figure it out. Okay, I need to nums I plus 1, nums high. I need to swap those, which means this needs to become nums high and nums I plus 1. Then we're going to return I plus 1. No, sorry, yeah. I misread your thing at first, and then I realized what you were saying. I apologize. But we don't need to know. We learn together. That's the fun part. Okay, I had a feeling this was wrong. That's fine. Nums I is just trying to keep it real. Yeah, dude, it's the best way to go. Okay, what did I mess up? So, which part didn't it like? I feel like this is what I'm doing wrong up here, but let's just start down here. So nums, low minus 1, range, and low. Pivot, set pivot to the element at index I. I did that. Set I to the index before low. Low minus 1. For each index j in range low high. Okay. If the element at index j is less than pivot, that's fine. I plus equals 1, yes. Then we need to swap the element at index I with the element at index j, which is what I did. But why didn't it like that? Unless it's out of range. Why, though? Why is it out of range? Is it something to do with what I did here? Do these need to be nums? No, because that's the element. I don't need the element. I'm just looking for the positions. So this is fine. Okay, but something is not fine. So for each index j in range low high, if the element at index j is less than the pivot, we did that, I plus equals 1. Then swap the element at index I with the element at index j, and that's what we're doing here. I think it has something to do with what is up here. What if I just want to check out some things. Print nums low and high. I'm interested to see what is actually in here. Can I see this? No, it doesn't like that. Oh wait, I guess I can do it up here. Print nums low high. Will that show up? I just want to see what it is. Okay, so it's an index, the numbers, that makes sense. Or it's a array. And low and high are 0 and 2. Okay, so let's go back through here. If low is less than high, so low is 0, high is 2, then it would do this. The middle is running the partition, which is this. Can a range start at 0? Does it have to be 1? It can start at 0. Oh, I'm just an idiot though. Oh no, I'm not. Maybe I'm not. Hold on. Set to the index before low. Hold on. I think I just need this. Yeah. I was just calling the wrong thing. I was calling the element instead of just the number on that one. I was just being an idiot. Classic. But I can get rid of this now. I don't need that. That should work. Okay. That was also super fast. I see why they're saying that quicksort is super fast. We were pretty close. That's not bad. I only messed up the one thing, and it's because I was here and I was calling the index, or I was calling the element at the index of low -1. But what I really needed to be doing was I needed to just be setting I to that index number, which is -1. That makes sense. Okay. Let's press submit and see if we actually did it right and pass all of the other tests. Yeah! Boom! I -1, baby. It's all about I -1. I do get confused, and I'm actually happy reading the pseudocode, and I just got to keep remembering that, like, when it talks about the element at index, then it's using the, you know, the nums1, because I'm calling the actual number or item at that index. And when the pseudocode just says that it's looking for the index, I'm not looking for the actual element at the index, and I just need to remember to do that. There you go. Nightshade. It's also fast because there's like 10 elements. Nightshade? Stop it. What's fast is how good we did it and how quickly we figured this one out. That's what really matters. But yes, there are very few elements in this one. We're still fast though. That was cool. I felt good about that one. Am I getting slightly better each day? Is that what's happening? Is there like a tiny incremental amount of progress and learning by doing this every day? Honestly, that sounds messed up. I don't believe it. That sounds like bullshit. Like that little kid. Bullshit. Okay, we are continuing. Sounds too good to be true. It does sound too good to be true. There's no way that practicing every day makes you better at things. Because if that's the case, I have to go back and relive my whole life. Because I was under the impression that if I tried something and I wasn't immediately the best at it, it meant I should quit and do something else. And if that's not the case, we're in trouble. Allen Iverson. Hey, this is a no AI. This is a no AI place. That was a better joke in my head, and I couldn't get it out. So instead, I just blew it. Classic. All right. Let's read this out. I also like Rust. Sorry, not sorry. Oh, dang. All right. Quicksort big O. On average, Quicksort has a big O of O(n) log n. In the worst case, and assuming we don't take any steps to protect ourselves, it can degrade to O(n)². Man, that's rough. Partition has a single for loop that ranges from the lowest index to the highest index in the array. By itself, the partition function is O of n. The overall complexity of quicksort is dependent on how many times partition is called. So, worst case, the input is already sorted. That's actually really interesting to me. Like, I know you can guard against it, and I'm sure that's what we'll talk about, but it is funny to me that the thing that messes up an algorithm for sorting the most is the fact that the list is already sorted. Doesn't that feel weird? Is that just me? Like, I get it, I think, but it also seems wrong. And I know that you can check for those things first, which is, I'm sure, what they're going to say. But it is weird. It's a weird thing to me. Anyways. Where was I? Best case. Best case. The pivot is in the middle of each sublist, which results in log n calls to partition. I shouldn't have done an accent because I don't know what I just read. The pivot is the middle element of each sublist, which results in log n calls to partition. Oh, because I see. I see. Okay. That's our reference. We already did that. What causes a quicksort to break down to O of n squared? Who's got the answer? I know my answer. Is it an unusually large list, an already sorted list, a small list, or a randomized list? Put your answers in the chat. You guys even paying attention? What the fuck? What am I even doing here? Why am I even trying to entertain you? I'm just messing with you. Just so everybody knows, I'm just messing with you. I'm entertaining myself and myself alone. That's always the goal. And the answer is 2. Correct? B. Rick, it's a 2, not a B. But we'll give it to you half points for not reading that your choice was a 2. 2. We did it. I wasn't looking. Get out of here, Rick. Shot from the hip. That's good. That's some good shooting there, Rick. What is Quicksort's worst case big O complexity? O of n squared, O n log n, O n, or O log n? Worst case is option 1. That's a good choice. I like it. I'm going with option 1. We did it, team. Thank you. We did it together. This was our experience together that got us through that question. So thank you. Lua would like a word. Dude, I love Lua. That was for the last one. This one's option 0. Oh, you know what? I just thought you were doing Lua, like Rick said. So I love Lua and their one-based index. So whatever you say, Nightshade dude. Now you're wrong. You just got an out-of-index error with your option O garbage. Man, what am I? A developer with these jokes? Fixing Quicksort. While the version of Quicksort that we implemented is almost always able to perform at speeds of O n log n, its big O is still technically O of n squared due to the worst case scenario. The first element is option 0. Not in Lua, Nightshade dude. So, there. I actually don't even know if I'm right. All I know is I remember, it is Lua! I'm Lua! We are Lua! The world is Lua! Okay, at least I was right about Lua. Hey, Nightshade dude, as moderator, can you ban the host? Is that a functionality that you have? Because if so, I should be a lot more nervous. All right, I'm reading this. I've tried no can do. Well, okay. Well, that's good then. Good, that's good for me. Its big O is still technically O n squared due to the worst case scenario. We can fix this by altering the algorithm slightly. 2 of the approaches are shuffle input randomly before sorting. This can trivially, it's a weird word, be done in O of n time. Actively find the median of a sample of data from the partition. This can be done in O of 1 time. Random approach. The random approach is easier to code, which is nice if you're the one writing the code. That's fair. The function simply shuffles the list into random order before sorting it, which is an ON operation. The likelihood of shuffling a large list into sorted order is so low that it's not worth considering. You able to pay for my dictation fee from earlier? Thales agreed to $200 flat fee. I said $200 flat fee with no mistakes. And it was pretty terrible. Sorry, man. Oh, hold on. 1 second. I think some people are home. 1 second. I gotta see if my kids are here. They're supposed to be going to piano. Okay, I'm back. Sorry about that. I was not expecting anybody to be home. And, and then apparently my wife's plans got canceled. And so she's taking the kids. And so the kids showed up. Life, man, you know? Now they're supposed to be getting out of here and going, and we're going to finish our lesson. Oh, Theo's streaming. Hey, we should raid Theo if you guys stay in long enough. That'd be fun. He'd be like, I've never raided Theo before. Okay. Anyways, let's do... What time is it? 4:40. Oh, we only have that much time left. We're going to finish what we can. We're going to do what we can, and then we're going to do some raiding. The random approach is what we were reading. Yes. Yeah. I'm keeping an ear out in case the kids need anything before they leave. Just so you know. The function simply shuffles. We read that. Median approach. Another popular solution is to use the median of 3 approach. 3 elements, for example, the first, middle, and last elements of each partition are chosen, and the median is found between them. That item is then used as the pivot. This approach has less overhead and also doesn't require randomness to be injected into the function, meaning it can remain deterministic and pure. In the age of AI, does anybody even care about non-deterministic? or being deterministic. Whatever. Okay, what does shuffling quicksort's input do? Practically ensures a runtime of O n log n. Boom. 2. Done. Crushing it. Why is the median of 3 approach sometimes used? It doesn't require randomness and impurity. That's the answer. To use less space on disk? No. To make the algorithm harder to understand? No. Because it's easier to implement? No. No. It doesn't require randomness and impurity. It's like, who even is this guy? Maybe I've just been faking it this whole time, and I'm actually an incredible developer. Did you guys ever think about that? Huh? Did you ever think about that? No? Didn't think so. Okay. I think we finished Quicksort. Oh, why use Quicksort? Why use Quicksort? Pros, very fast. At least it is in the average case. In place, saves on memory, doesn't need to do a lot of copying and allocating. Cons, typically unstable. Interesting. Changes the relative order of elements with equal keys. Oh, right. Okay. Versus like, versus the what the heck was it called? Oh my gosh, insertion sort, where it was stable because it didn't change the relative order of elements with equal keys. Recursive can incur a performance penalty in some implementations, and pivot sensitivity, if the pivot is poorly chosen, it can lead to poor performance. All right, fair enough. All this said, Quicksort is widely used in the real world because the trade-offs are often worth it. For example, it's a default in PostgreSQL. Ooh, I've never said that out loud. Do you say, is that PostgreSQL? PostgreSQL? What do you say, internet friends? A popular open source database. I'd also like to shout out TimSort, a hybrid of merge sort and insertion sort that was Python's default from version 2.3 to 3.10. As of Python 3.11, it's been replaced by PowerSort, which makes small but meaningful improvements. Postgres? Oh, we don't even talk about the QL. We're just like, forget that QL. I see how it is. I get it now. I get it. There you go. Okay, so if you need a stable sorting algorithm, which would you use? None of these. Is merge sort stable? No. It can't be, because it messes everything up. Quicksort is not. No sorting algorithm is stable is not true. And I don't think merge sort is. So I'm picking none of these. Dang it. Is it merge sort? Son of a bitch. I was so confident. Fuck. I was so sure. I was like, oh yeah, I remember. We did that insertion sort, and that one said it was stable. I don't remember merge sort saying it was stable. Son of a man. Absolute ridiculous. Okay, anyways. Which would you be more likely to use in a large production system? You would use bubble sort. Gotcha. Quicksort. Nailed it. Okay. Okay, so let's see. We've only got, I got like 10 minutes and then I gotta go. So we could either, I think we might just call it since we're about to start selection sort, and that's a whole new jam. Maybe we'll go raid Theo, and then that's it. I'm excited though, man. This has been 8 days. I said I was going to do it Monday through Friday, 3 to 5. This is 8 days in a row of doing it. And I appreciate the fact that this is happening and that people are showing up and having some fun. And I'm having a blast. Let's raid Theo. Thanks, man. Thanks for the claps, Nightshade. Hey, you have been a huge momentum builder. I really appreciate you coming in and doing this. You're a good dude. Are you also a mod in Theo streams? since you're basically a mod literally everywhere on Twitch, it seems like. Nope. I'm surprised. We should force him to make you one. Okay, let's go into Theo. Why not? I think it's just you and me, and maybe I'm not sure if Rick's still here, but Rick, if you're still here, we're gonna go right into Theo. Wait, no, don't rage into Theo. No more mod. Oh, you don't want to be a mod anymore. I think it's very heartwarming that you actually take it somewhat seriously, and because if everyone just added me as a mod, I would just be like, I am not paying attention to your ridiculousness. Okay, thank you again. I'm gonna start a raid. I'll go hang out with Theo for a few minutes while we're in there. I'm just gonna turn off this music, and yeah, let's go hang out with Senor Theo. Start some raiding. And it's just you and me, Nightshade. Can't wait. All right, guys. Thanks again. Really appreciate it. See you tomorrow.